Okay, so how does this problem work? So we are given a bunch of sequences of parentheses, and we want to find pairs such that the pair forms a valid sequence. We want to figure out how many we can make. So there's n different sequences, and there's a lot of sequences, and they are potentially long, although the total length is not that long. And the same sequence can appear multiple times, whatever. Okay, so the important fact about this problem is that every bracket sequence can be reduced to some number of right parentheses followed by some number of left parentheses. So the point is that the way that you sort of reduce a bracket sequence is you keep deleting sort of this balanced unit left right until eventually you have no more left rights. And because there are no more left rights, that means that it has to be of this form, right? Because if there was, all the rights have to come before all the lefts, otherwise there would have to be a left right somewhere. So that's the important theorem for this problem. So actually, for this problem, we can say more, because we only get to match up two things to form a valid sequence. So if we actually have both rights and lefts, there's no way that you can form a valid sequence by adding just one thing on either side of this, right? You need to add something on the left to deal with these rights, and something on the right to deal with these lefts. So actually, anything that can be paired up is going to only be rights or only be lefts. So that is what we're going to do. Is we're going to take everything, we're going to figure out, so there's three possibilities, right? Either it's already balanced, so it reduces to the empty string. We're going to keep track of that separately. Or it's just a bunch of right parentheses, or it's just a bunch of left parentheses. And we're going to pair up. So of course we need to pair up the rights with the lefts, right? Like right pairs up with left. So in the problem statement, it seems like there's some ambiguity about, like, we have to make choices about what pairs up with what, and maybe we can make bad choices. But that's not actually true, because everything is of the form that we just talked about, right? It's either some lefts, nothing, or some rights. Nothing pairs with nothing, and the same some lefts pairs with the same number of rights. So that's the form of our solution. We are going to read in n, then we are going to read in these strings, and we are going to parse them into an integer, which is just, it's either 0 for nothing, or negative for lefts, negative for rights, or positive for lefts. Or it doesn't parse, that is, it parses into some rights and some lefts, which we know we can't pair. So we're going to represent that by just returning infinity, or whatever. So if it parsed, then if it's positive, stick it in the positive map. If it's 0, keep track of the number of zeros that we got. And if it's negative, just add it to a list. And so the zeros all pair up. If there's an odd number of zeros, we can't pair up the last one. And then we just go through all the negative numbers, and we just try to pair them with a positive number. And if there is no positive number, then we can't pair that one. And that's it. So the only thing left to do is to figure out how to actually parse this string. So we can just do sort of the stack-based bracket parsing. So you go through the characters. Basically, we're going to follow the algorithm that I said, which is that the way that you reduce a bracket sequence is you just delete all of the left rights. So we're just going to keep track of the left rights. So for each new character, if it's a right and the last thing that we saw was a left, then delete that pair. And otherwise, just stick it on the end. So this is going to effectively delete all of the left rights in the string. So every time we see a right, we're going to see if we have a left to pair with. Okay, so if there's nothing left, then it's a 0. So otherwise, figure out how long it is and figure out what the top character is. So now we need to check that all the characters are the same. Otherwise, we have an unparsable thing. Okay, so just go through the stack and check if a character is different, then mark that. And it's just enumerates through the whole thing in the stack. So if they were all the same, then return the size and whether it was left facing or right facing, positive or negative. Otherwise, return this special value that means it's unparsable. So yeah, that's the whole problem. We just classify all the sequences and then we pair them up in this greedy way that has to work. So that's it.